Okay, Bismillahirrahmanirrahim. Assalamualaikum. Today I'm going to show you uh, a new topic in R, which is Introduction to ggplot, right? So, basically, this topic is to produce useful graphic using ggplot2 package as quickly as possible. Before we start, just want to emphasize that for this material that I'm using is based on a ggplot2 elegant graphic for data analysis book, second edition by Hadley Wickham, Springer 2016. Right, at the end of the topic, you should be able to know some uh, about the MPG dataset that included in GG2 package, and then you should be able to know three key components of every plot, which is data, aesthetic, and geoms. And you should be able to know how to add additional variables to a plot with using aesthetic, right? And you will able to display additional categorical variable in the plot using a small multiple created facet by faceting, and a variety of different geoms that you can use to create a different type of plot. And you also will learn how to modify the axis, x-axis and y-axis in a graph, and things that you can do with a plot object other than display it, like save it to the disk. And Ggplot, I think in this video I'm going to hold Ggplot for a while. We will continue the Ggplot on this next video, right? Ggplot is actually a handy shortcut plotting when you just want to quickly bang out a simple plot without thinking about the grammar at all, right? So let's look at the first topic that we're going to discuss today is introduction to fuel economy data. But before we start with the fuel economic data, so you need to first install the ggplot package if you not do so. So if you did not install yet, you just hit install package ggplot2 and hit enter. Since I already have I already installed the ggplot package, I need to load the ggplot package by library ggplot. So we're going to use mpg dataset, which is a fuel economic economy data. So it's actually is the information of or the data about the fuel economic of popular car model from 1999 to year 2008. The data was collected by US Environmental Protection Agency. You can find it by go to http double slash fuel economy.gov. So the data you can get the data here, but by using ggplot2, the data are already imported into ggplot2, right? So as you can see, the variable are mostly self-exploratory lah. So we have basically, if you want to know the name of variables, mpg. So we have CYL, CTY, and HWY record mile per gallon mpg for city and highway driving. DISPL is the engine displacement in liter. DRV here is the drivetrain, front wheel, rear wheel, or four wheel. If you can see the, the distribution, the level of DRV, MPG, DRV. So we have four wheel, this is front wheel, and this is rear wheel, right? And then we have model here is the model of the car. There are 38 models, right, selected because they had a new edition every year between 1999 and 2008. So if you can see table, maybe this is going to be a bit messy, right? Table model, going to display 38 models of the car, right? If you could put length of the table, right? So we have basically 38 models, right? And the class here for in the variable inside of MPG car is a categorical variable that describing the type of car, whether two-seater, SUV, compact, or so on. If you can see from the table itself, table function, MPG class. So we have basically some class of the cars: two-seaters, compact, mid-size, minivan, pickup, subcompact, and SUV. Right. So this dataset suggests that many interesting questions, right? So how are the engine size and how fuel economic related, and do certain manufacturers care more about fuel economy than others, right? This is the equation that we can ask for the dataset. Before we start with the analysis, we need to ask some question to get familiarized with the dataset. Some more question that we can ask is, has fuel economy improved in last 10 years? And we will try to answer this question. But I think I'm not trying to answer this question. But I think if you have time, can try to answer this question, right? I've leave you some exercise, right? This exercise are taken from the book of Hadley Wickham. So this is going to be your assignment, right? Are you okay with that? If you can pause the video for a while and copy the question and try by yourself and explore, get familiarized with the dataset for a while before we start with the ggplot, right? So we need to proceed now. In order to understand ggplot package, there are three components that very important in developing or constructing a plot using ggplot package. Right, first is data. Data is we need to our data is MPG, right? So we need to call the data for a data definition, and a set of aesthetic mapping between variables in the data and visual properties, right? Which is our for example, x variable and y variables. And the last component are geom, which is at least one layer which describe how to render each observation. Right? Layer are usually created with geom function. So for example, let's say we use ggplot. If you can see, you need to pay attention to the structure of this function call. The data and aesthetic mapping are supplied in ggplot, right? So then we are added on with plus. This is an important pattern, as you can learn in more about ggplot2. Will construct increasingly sophisticated plot by adding more type of component. This is a component that we're going to construct, geom point, which is our scatter plot. So first I define my data and my aesthetic mapping. Under aesthetic mapping, I define the x variable and y variable. X variable going to be on x axis, y variable going to be on y axis. So if I hit enter, so it will appear a scatter diagram for HWY and display replacement, right? So this is the scatter plot, right? So almost every plot map variable to x and y, right? So naming this aesthetic is very tedious. So the first two unnamed argument is aesthetic will be mapped to x and y. This means that the following code, this one, right, is identical to the above code, right? So means that the first aesthetic is already known as x variable, and the second aesthetic is also known as y variable. We don't need to specify x equal to what variable, right? It's just understandable by ggplot package. So if you can see, if I hit enter, I will still get the same result, right? So I will stick to use this style, right, throughout this lecture. So don't forget that the first two arguments of the aesthetic are x and y. So if you can note that every time I run the code, I put each command on a new line, right? So I recommend doing this in your own work code, right? So it is easy to scan a plot specification and see exactly what's going on there. So in this lecture, I sometimes use just one line per plot because it make me easier to see the difference between the variation. The plot shows, based on this plot, you can say that the plot shows the strong correlation, right, which is a negative correlation. As the engine gets bigger, right, the fuel economy get worse, right? There are also some interesting outlier, right? Some cars have a large engine, right, gets higher economy than average, right? What sort of car do you think that they are, right? You can explore by yourself, right? This, I'm going to leave you another exercise, right? So just take a moment to explore this exercise and try to answer very careful. If you have some question about the exercise, you can leave a comment to at the section below, right? So you can pause this video and copy the question, right? So we're going to continue on the next section. So the next section is about color, size, shape, and other aesthetic attributes, right? So to add additional variable to plot, we can use other aesthetic like color, shape, and size, right? This color, shape, and size is work in same way as x and y aesthetic, right? They are added into the call of aesthetic, right? If you can see, I add color under aesthetic, AES. Shape also added under AES, and this one should be comma, yeah. Okay, so ggplot take care of the details of converting data, such as, for example, F, R, 4 into aesthetic. F is, or another example is red, yellow, and green for the scale. Right, there is one scale for aesthetic mapping in a plot. Right, the scale is also responsible to create a guide, an axis, or a legend, right, that allow you to read the plot, converting aesthetic value back to the data value, right? For now, we will stick the default scale provided by the ggplot. We will try to adjust in another video, right? Right. To learn to learn how to learn more about those outlying variable in previous scatter plot, we could map the class variable into color, right? For example, let's say this one, the previous plot that we already plotted, right? We can differentiate the class of the car, right, by different colors, right? So we can use color under aesthetic for a class. So for example, let's say look at this one. So we're going to we're going to color the car, the class of the car based on this size of engine, right? If you can change this one is for color. Let's say I change this one shape into geom point. So for a geom shape, it will change the data point based on the class, right? This one also same size, it will change based on size, geom, right? And notice that you can combine these two together, right? If you can see this one, I can add size and color together. If you can see here, let me paste here, color equal to class, sorry, it's CYL, right? And plus geom underscore point. Yep. So it differentiate the size and the color, right, together. Okay. So basically, if you want to, for this example, let's say I plot a graph based on class, and the class is changed, differentiated by color, right? So let's say I want to set an aesthetic to a fixed value without scaling it, right? To do so in the individual layer outside of AES, right? If you put under AES, it will not obey your instruction, because the default AES is for the color is red, right? If you can see for this type of command, I put color under AES, right? So I want blue color. It will not appear blue color. Instead, it will appear the red color for you, because the default scaling for color is red. So what you need to do is to put the color instruction outside the AES aesthetic mapping for the geom. Then we'll get the blue color, right? So if you can see in the first plot, the value blue is scaled to the red color, and the legend is added. The legend of color is added. So in the second plot, right, the point are given in the arc color blue, right? This is important technique that, and you will learn more on the next section, the next video, right? So if you want to know more on the spec of the ggplot, we can go to Winigate, net ggplot2 spec, right? So, oops, specs. So aesthetics specification. So we can see a lot of the documentation of for aesthetic are labeled here, right? You can explore by yourself, right? So the different type of aesthetic distribute work better with different type of variables, right? For example, let's say a color and shape work well with the categorical variables, and while size work well for the continuous variables. You just need to take note this one. Color and shape work well with categorical variables, while the size work well with for the continuous variable. So the amount of data also make difference. If there is a lot of data, it can be hard to distinguish different groups. If you have a lot of data, it's kind of hard to distinguish different groups. Alternative solution is to use faceting, right? So we're going to explore faceting next, right? When using aesthetic in a plot, less is usually more. It is difficult to see the simultaneous relationship among color, shape, and size. So exercise restraint when use aesthetics. Instead of trying to make one very complex plot, try that show everything at once. Uh, try to see, try to create a series of simple plot that can tell a story, leading the reader from ignorance of knowledge to knowledge. Right, so I'm leaving you this as a exercise, so you can pause the video for a while and copy the question. Right, moving on. Right, we're going to focus on faceting. Faceting is very simple. Right, another techniques for displaying additional categorical data, categorical variable on the plot is faceting. Right, so faceting creates table of graphic by splitting data into subset and displaying the same graph for each subset. Right, you so there are two types of faceting, which is grid and wrap. Wrap is most useful function. So we're going to discuss on wrap here. So you maybe we will discuss on grid later on the next video, right? To facet a plot, you simply add faceting specification by facet wrap function, right? So it will take the name of variable preceding by tilde, right? You need to add tilde as well, right? So for example, let's say I'm going to display a box plot. Let's say I'm going to display a point plot lah, right? Bar chart, scatter plot, right? So this is going to work well. So this is the standard definition that I am using previously. So I just add facet wrap by class. We know that we have several class of the car. So it will produce, oops, yeah. It will produce a several plotting, right, by faceting the class, right? Two-seater, compact, mid-class until SUV. Right, so you can see the x-axis represent displacement, which is your engine size, and HWY is your economical fuel, right? So again, I'm leaving you with this point and leaving you with the exercise. Go and try to explore the faceting wrap by combining the knowledge that you have learned previously, right? So if you have a question or you stuck, please comment and please tell me you stuck, right? So then I will try to help you when we are in the class. right? So what you need to do is just pause the video and copy the question, right? So we're going to continue next, which is the third components in ggplot, which is geoms. So previously we already learned how to plot a scatter diagram using a geom point, right? So maybe you might guess that by substitute geom point for a different geom function, right? For to get a different type of plot. So maybe you're right, right? So there are several plot that we can use under geom. So for example, the first one is geom point is for scatter diagram. Geom smooth is feed a smoother to the data. Geom box plot produce a box and whisker plot. Geom histogram and geom frac poly, F-R-E-Q, frac poly also shows the distribution of continuous variable. Geom bar is a bar chart distribution of categorical variables. Geom pulse is a line between data point. Geom line also line chart. Geom violin, it shows a compact representation of the density of the distribution. Right. Let's look at smoother plot. To smoother the plot from a scatter plot, we can add a smoother line by adding geom smooth. Right. So if you can see, if I just highlight this one, right, without plus and the second plus, so I will get the scatter plot. Right. So if I want to add a smooth line, the projection line around between the around the data, so I just add smoothed line, right? Right. So these overlays of the scatter plot, right? See, these overlays of the scatter plot with a smooth curve, including an assessment of uncertainty in the form of point-wise confidence interval, right? Shown in gray. This is a confidence interval, lower confidence interval, lower limit and upper limit. Right? If you are not interested with the confidence interval, you can turn it off by using geom smooth SE equal to false. Let's say I change it to this one, to turn off confidence. Right, just SE equal to false. Right, so we can see there are no more confidence interval overlay the plot. Right, so it's also important argument to the geom smooth is the method, right? It's a method of plotting the line graph, which is also allow you to choose the method of in under geom smooth allow you to choose which type of model is used to fit the smooth curve, right? For example, if the method is lows, right, lows is by default, right, for a small n. If you have small n, you don't need to um, mention method equal to lows because it's by default and is designed for small sample size, right? So you can use regression smooth, right? If you want to know more about lows, so it's a local polynomial regression fitting. So we have you can specify a method. Where is the method? Nothing much explained in this document. Methods fitting the model or extract the model frame can be abbreviated, right? So for the line chart, we can also change the wiggly curve or smoothing the curve by change the span equal to 0 until 1, right? So if span is less than 0.5, it will smooth wiggly, and if span is equal to 1, it will smooth not so wiggly, right? So we also can fit the line using a linear regression model using method equal to LM. So this is the most common method that used in other software such as SPSS, IBM SPSS statistics, right? So we put method equal to LM, linear model, right? We will get the linear line here, right? And don't forget, they are also giving us confidence interval. We don't want confidence interval, right? So we can get the smoother line, right? We also can add using the line and using generalized additive model. Just change to GAM and add some formula here, right? And we also can use for robust linear model, right? Robust linear model is basically from mass package. So first, before we use the robust linear model, we need to load the mass package first and plot a point, right? I think that's all for a smooth line, right? So next we're going to look at box plot and jitter plot. So when a set of data include a categorical variable and one or more continuous variables, right? You will probably be interested to know how the value of the continuous variable varies with the level of categorical variable, right? So say that we are interested in seeing how fuel economy varies within car class, right? So we might start with the scatter plot like this, right? Right. So we have a car class. This is a the front wheel, rear wheel, and four wheel, right? So because there are few unique value of the both class and HWY, um, there is a lot of overplotting, right? Overplotting, right? So many points are plotted in the same location, right? So it is very difficult to see the distribution of the class, right? So there are three useful techniques that can help alleviate the problem. First is by using jitter plot, box plot, and Weiling plot, right? So the box jitter plot is by using a geom jitter, right? It adds a little random noise to the data, which can help to avoid overplotting. So by using the same data and variables, right? So we add geom jitter or at the back, so we can see there are some noise over here. So somehow it's very difficult to plot to interpret, right? But we know that the front wheel is quite higher compared to four wheel and rear wheel, right? So we can change to box plot if you want, right? Just change geom box plot, right? So it will give nice graph and more easy to interpret, right? And violin graph shows a compact representation of density of the distribution. It highlights the area where the more point are found, right? This is a more point are found, right? This is a more point are found. So for each method, right? has its strength and weakness, right? Whether the jitter plot or box plot or violin plot. So box plot basically summarize the bulk of the distribution with only 5 numbers, right? Minimum value, uh, quarter one number one, quarter number two, quarter number three, and maximum value, right? While jitter plot shows every point but only work with relative small data set. Violin plot, otherwise, in other hand, give the richest display but rely on the calculation of density estimate, which can be hard to interpret, right? So for the jitter point, right? For the jitter point, where is our jitter point? Right? Geom jitter offer the same control over aesthetic as geom point, such as size, color, and shape. For the geom box plot and geom violin, right? So you can control the outlier color by or internal field of color, right? Okay. So for the next graph is histogram, right? The histogram and frequency polygon shows the distribution of single numeric variable. Numeric. You need to understand this is for numerical variable. They provide more information about distribution of a single group than box plot do, right? At the expense of need more space, right? So if you can see the histogram, so I'm using HWY because this is a continuous variable. So we'll produce the histogram with 30 bins. It will slice the the data into 30 parts, right? Same goes to the frequency polygon graph, right? By default, it will slice the data into 30 parts. Right? Both histogram and frequency polygon work in same way. They bin the data, they cut the data, and then they count the number of observation in each bins, right? The only difference is the display lah. The only difference of histogram and uh, frequency polygon is the display, right? The histogram use bar, right? And frequency polygon use lines, right? You can control the width of the bin by using bin width, right? Bin width argument, right? If you don't want evenly spaced bin, you can use break argument, right? So it is very important to experiment with the bin width. The default just split your data into 30 bins, right? Which is unlikely to be best choice lah. You should always try many bin widths, and you may find you need multiple bin width to tell the story of the data, right? So for example, you can change the bin width to 2.5, right? It become like this. If you change the bin width to 1, it become like this, right? So so basically, you can also do comparison of the distribution using histogram, right? By applying the faceting function, this will make a comparison a little harder, but it is easier to see the distribution of each group, right? For example, let's say I'm using histogram bandwidth with 0.5, and I'm facet by class, right? So if I'm not specifying anything under facet right, right, they will facet by row, right? And by row is equal to 1. If you want to facet by column, right, you need to spell n col by equal to one. I think it's nice to put by row, right? Okay, for the next graph, right, is a bar chart. Bar chart is very simple. I'm not having much example on bar chart, but there are two type of bar chart we can construct from the unsummarized data and summarized data. Summarized data, unsummarized data means from the MPG. Let's say we look at head MPG manufacturer. So you have Audi, right? And you need to remember that for bar chart, the it is on this is designed for the bar chart is designed for categorical variable. So you need to have in this example I have only single variable lah, because this is unsummarized data. Right? If you have a summarized data, means Audi is how many the frequency of Audi, and next Mercedes how many frequency of Mercedes and so on. So it's called under summarized data. So if the data is scattered, not summarized, then you can use geom bar. It will call the bar chart for each manufacturer. So if you have summarized data such as the data of PG mean, if you want to look at PG mean data, you need to first load the G codebook data, the library. So we're going to use PG mean, right? So under PG mean, I have two variables, group and weight. So this is summarized data. So under control group, weight is 5.032. Treatment 2 is 5.26. So we need to add some parameter under geom bar, which is stat equal to identity. Right? And then we need to specify our x axis and y axis as well. Right? Okay. So for the summarized data, it is not best to construct a bar chart for summarized data. Usually it works well on bar scatter diagram, right? So the next plot that I'm going to show you is a line plot. This is a line plot is actually used for time series data, right? Line plot join the point from left to right, right? While path plot, right? Remember we have a line, geom path is do the same task, right? The path plot join them in order that they appear in the data set. In other words, the line plot is a path plot of the data sorted by X value. The line plot usually have time on the x-axis, showing how a single variable have changed over time, right? So path plot shows how two variables are simultaneously changed over time, with the time encoded in the same way, in the way that observations are connected, right? Because the year of variable in the MPG dataset is only two values, right? So we cannot use MPG dataset to demonstrate the line chart, right? So we're going to use economics dataset, right, which is available in by default in library of dataset, right? So you don't need to install any packages, right? So the economic dataset contain the economic data on US measured over the past 40 years, right? If you can see, let's see, I call dimension economy, right? We have 574 observation of 6 variables. Head economy right? So I have date, PCE, population, and so on. So we can already see some different in these two variables, right? So let's say I want to plot unemployment over population and with date, and I add geom line at the end, right? So I will get a line chart, right? So the next one also same, right? Okay, so I think the geom part I'm going to stop there, right? Because we're going to discuss in detail on the next video. This is just a um, introduction video for ggplot, right? So but before we end the topic, I'm going to focus on I'm going to touch on two topics that we going it's very simple. If you want to modify the axis, x-axis and y-axis, you want to add label for x-axis and y-axis. Let's say if you want to add label for x-axis, you just add xlab and code your label, right? For example, let's say I just highlight this one. So for this one, if you can see, there are no label defined on x and y axis, right? So if you want to define x axis as city driving and y axis highway driving, so we can add x lab and y lab. So if you can see here, there are label for y axis and x axis. So if you really don't want the x label and y label, you should put null for x label and y label, right? For example, if you don't want uh, label for x axis, you just type null. If you don't want the label for y axis, also type null, right? So there we're going to eliminate going to omit the label for x and y axis, right? And of course, and for the last, when you finish your constructing the graph, you want to save the graph, right? So for example, most of the I'm going to store this graph, right, to P, right? So to object P. So if you want to print P, just print P. You're going to display the P, the graph that you already construct. So if you want to save the graph to this, right? Just type gg save, and what is your graph name, right? Say plot.png, right? And your width equal to, let's say, 9, and height equal to 6, right? So it's already saved it into your working directory. To know where is your working directory, get wd. This is my working directory, so I can find it here, Muhammad Nasir Abdullah. So oops, so this is the plot that I already saved, right? Okay, right? I think I'm going to stop here, right? We're going to continue on the next video on Ggplot, for a quick plot without caring with it of the grammar of the ggplot, right? If you have any question, right, you can comment on the below section, right? See you, bye.